Does it just check that it's working on? Yep. All right, before we get started, we just wanted to thank everyone for coming in today. So I know we have a lot of parents, but also people that came in without students just to see what we've been doing, helping support the PLTW program. So thank you for coming in. And I hope that we'll at least show you what we've been doing for this entire last year. So, I mean, it's been a long process. Most of us have been part of this program since freshman year. So we kind of like been learning a lot. And now this year we were able to use all of those skills that we have been building up since even before freshman year, building up through programs like PLTW, building up in clubs like robotics, and now being able to apply them to a product that we have been working on and researching and just, well, dwelling into for an entire year. So thank you all for coming. I think we should be all good to go then, right? All right.
All right. Hi, my name's Aiden. This is Adrian, and that's Alex. We're Pinnacle Winter Sports. We are a group of high school students that have spent the last year researching a problem with skiing and developing a solution for it. Alex will talk more about our problem.
Okay, so our problem is that skiers that use ski poles with straps, they tend to, when they fall, their hand gets stuck in the strap, and so they can't pull away from the ski pole. And so the ski pole gets stuck between their thumb and their pointing finger. And then so when they fall and hit the ground, their thumb gets overextended and their thumb becomes injured.
So what this is called is skier's thumb. So it occurs a lot both within and outside of skiing. So this happens when there is a tear of the ulnar collinear ligament, so the one essentially connecting the thumb and the index finger. And essentially, in most cases, this is about 6 weeks of recovery. So during that time, possibly needing a splint or something like that to be on your hand for the most severe cases. So something that you kind of don't want to get when you're skiing.
So before we started developing our solution, we wanted to look into previous solutions that are already out there to know if we were trying to solve a problem that's already been solved or if there were improvements to designs that could have been made. We found 3 main other products that exist out there. So the first product we discovered was called the Scott SRS ski pole system, which fully disconnects the ski pole from the strap using a spring pin system like this. This is actually an SRS pole. The issue that we found with this design is that it's an easy loss of your pole. So if you're falling and you lose your pole and it's 50 feet up the hill, you can't really get that back very easily, and ski poles are expensive. And also it takes quite a bit of force to actually pull the strap off, so it's not a completely like passive system. You have to actively try to pull up as you're falling, which as you're falling can be kind of difficult to remember to do.
And then another product that we found is a Japan patent. And so it uses magnets to connect the skier to the ski pole. But a problem we found with that is that it needs a specific glove with a magnet attached to it at the end. And then another problem is that when it releases and it disconnects fully, so that means that you could lose the ski pole.
And then another one that we found was the Lecky Trigger 3D. This one works similarly to the other products. However, this one also involves the use of a glove that you essentially strap your hand into, so the glove is connected directly to the ski pole. This allows for a wider range of movement. So with the previous solutions, what often happens is that you need to at least partially move your hand in order to get started and actually have the mechanism release. However, for this one, it was partially able to do that on its own due to its wide range of essentially engaging itself. But however, with all of these, we found major issues, especially with a person needing to direct the movement, but also it possibly needing another part, like the glove in the case of the Japanese patent and the Lecky Trigger, for it to actually work.
And for understanding factors, we made a list of them. And so for the first one, is skier self-prevention, which is our problem. And so it's our top, it's on the top of our list. And it's basically just preventing that overextension of your thumb. And then the next one is durability. We want our solution to be durable and withstand the impact of the fall. And we also want it to last the season and be also withstand the weather. And then we have no maintenance. We just want our solution to be easy to use, less work for the skier, and not create more problems. And then we have comfort and still functional. So we just want our solution to, again, just be comfortable and still function like an original ski pole. And lastly, we have no additional risks, which is basically just not hurting anybody, not losing the ski pole after you fall.
Yep. So we essentially used the research that we did and looked at the products that were doing something incorrectly and essentially saw, hey, what do we want to improve with this? And that's how we came up with this list.
So after we came up with that list, we all went out and made our own design for the product, and then we came together after that. So we're going to tell you guys about our 3 own designs. So this is our spring-loaded handle design, and it's a way to force your hand off the pole using a spring. The issue that we have with this design is that you would need some sort of sensor to detect a fall, similar to like some smartwatches have or something, and we just don't want to like put batteries or something in a ski pole. But we did like how it was completely passive and it used the spring to force your hand off the pole.
We also had a strap extension idea. So this would work kind of similarly to the detection on the SRS system. So kind of by you pulling up manually, which is kind of how your hand automatically wants to move to get your hand away from the pole. But what this would do is essentially connect that to a string that is on a winch, so that when your hand starts pulling away, it lengthens that string, so that when you fall down, your hand falls in front of the ski pole with the ski pole trailing behind you. So it's still connected to you. However, it is not essentially within the range that you are likely to get trapped and then damage your ligaments.
Then for this design, it's a ski pole, and then there's a pole inside the ski pole in the handle, which falls down. But this also used a sensor, and so when you were falling, it would detect when you were falling, and it would retract the pole inside the handle, and then the handle would be hollow, and so then you could squeeze it, so then you wouldn't have to fall with your hand like this. You could fall with your hand like this, and then it wouldn't overextend your thumb. And then for our decision matrix, we put our 3 designs into it, and then we put the existing products also into our decision matrix. And then we use our deciding factors to find our final design down there, right here. And then we also use it to find which best 2 designs would prevent skiers thumb.
We also gave all of our deciding factors weighting. So like preventing skiers' thumb is obviously a problem, so that should be weighted a little more than all the other things that would give each of these items more points in the decision matrix. So we kind of weighted out what we wanted from our polls, put each of our designs into it, and then whatever scored the best is the design that we would want to try to iterate on. Which, going into our final design, we figured that we could actually combine the spring push system and the strap extension system. So we have basically the detection system on the strap extension system that Adrian previously talked about, where it just detects when you pulling up and retract it out. However, sometimes the winch would spin itself when it wasn't pulled up and out. So we used a spring from the spring system to hold the winch down, to lock it down. So that way your strap only extends when the mechanism is up.
So kind of going off of that, what we did, we went into CAD and started looking at, hey, how do we want to essentially incorporate this idea that we came up with and combined into actually being able to execute it and use it. So our system is essentially combined into 2 main parts. You have the outer mechanism, which is this part right here, and your inner mechanism right here. So of course you have your ski handle that you are holding onto, but then what you have is you have a strap, which is standard just like on any other ski pole, that is able to connect within this part here, so orange here, green right here, which essentially is able to hold that strap and essentially connect it to the rest of the mechanism. So what happens is that if you rotate this up, which is what would happen in the event of a fall, you are able to freely pull this out, which again is how your hand naturally moves, to be able to prevent your hand from falling onto the pole. However, when it's down, you are not able to pull it out due to the design on the inside combined with the spring and the tolerancing used here. Additionally, there are magnets to keep the position downwards in most cases, unless you are actively pulling up on it. That being said, we made sure to make those tolerances to be proper with what we wanted. So for example, we wanted to make sure that the gap between this green part, the rotator, and the bottom of the pole would be large enough so that a string could fit there, but not large enough so that it would be freely going outside of it. Additionally, a major factor that we looked at was cost. So being able to see what the product would actually be selling for, not only as a prototype and when we were making it, but also looking at comparable parts when actually being able to, if it would be executed as an actual product. With the main cost being something that is kind of dependable with a real product. The real product, you would be designing the poles yourself, which would make it a lot cheaper. However, these are the costs that we used within our prototyping.
And then so for our final prototype, here is, again, what he said, this one, this top video is us pulling up to fully extend the string and release the strap, and then this is the string fully extended here. And then this video down here is us pulling back or horizontal to show that it doesn't release when we pull away from the horizontal.
Yeah, so kind of seeing that in action. If I'm pulling this way, it's not really moving that much, but whenever I'm releasing it upwards, it does release fully. I don't want to release it fully because it's a pain to get it reinstated, which is something that we want to improve upon. That being said, going into our testing.
So we made a 4-step testing plan that we repeated 20 times for each ski pole to get consistent data. So the first step of our testing plan is to reset the system, make sure everything's back in the ideal working order. So we need to reset and respool the winch that's inside the pole. We do that just by spinning it up with our fingers. And then we want to pull directly backwards on the strap without rotating up. So that way our handle does not come out. And then after that, we want to document the length of the string beyond it if it does rotate or if it does come out, so that way we know how much it failed by. And then we need to reset and respool the winch if needed, if it failed that test. And then after that, we pull upwards on our strap like this, and then we pull out like our design's supposed to work. And then we document the length of the string beyond the rotator after it releases. And we had pretty decent results from our testing data, which Adrian can talk about now.
Yep. So starting off with the unengaged releases, so that is essentially something that we don't want. So when pulling backwards, it should not give a false negative. So essentially in its normal operating state, it should not be releasing the string. Something that we found though was in 23% of our cases, depending on how the string was set up, it would actually engage. With one of our poles, it was higher, about 35%, and the other one, it was only 10%. A major factor of this was the actual tolerancing that we'll get into in a moment, being a little bit too loose and allowing it a little bit too much room for it to freely rotate. However, depending on how much the handle was pushed down, this then was able to negate that. Similarly with our engaged releases, which is the one that we want for it to engage on, so when you're pulling up in the event of a crash, we found that 98% of our tests were able to extend, and they were able to go the full distance of the length of the string that we were prototyping with. And what this meant was essentially that when our tolerancing was extremely important and the exact setup would be. So any future design would need to deeply incorporate those ideas into its execution.
It is also important to note how much our failed trials did fail by. So if you look at the unengaged releases here, it did fail 23% of the time, but the string only ever came out half an inch, so it likely would not have impacted ski functionality that much. Now we're going to go into our design recommendations, which is what we think we should change based off of our testing results and data. So the number one thing we think we should change is a simpler reset system, which is our design can be reset and reused, but it kind of sucks to do it. You have to take the handle off and then like re-spool up this tiny piece of string and then put the handle back on. We think if we maybe put some sort of hole in the handle that you can just re-spool up the string, it'd be a lot easier. We also are considering doing a spring pin release system. We talked earlier about this hole here. It's just slightly too hard to release, but maybe we could use like a weaker spring or something because our magnets are just a little bit too easy. They do still work well, but this would just be kind of a better idea.
Similarly, as I was discussing, looking at tolerancing and being able to find the exact dimensions with it through testing and through more extensive models, and definitely using GD&T tolerancing, so making sure that the distances within the parts are equal to itself, not just in the total distance, but in terms of in relation to other parts of other components of that same part, making sure that it's the correct size. And then also a limitation that we had in our prototyping was the length of the string due to essentially the material that we were using and able to easily prototype with. And so that meant that we weren't able to prototype with a full 48 inches of string that we wished we would use, as that is about what we calculated would be ideal in the event of a crash. However, with this, we were still able to prove that the general concept was able to work. And we are glad that at least the idea as a whole is really solid, and that our execution did show promise with the idea, and that it could be further used and enhanced upon in these methods and more in order to actually be able to have it as a commercial product.
So beyond the takeaways for our design ourselves, we also have takeaways for how our group operates as a whole and how we work together throughout the year, and also just the design process as a whole. So our first key takeaway is that time management is a must. We found ourselves lacking time to finish this project. We kind of had to scramble and meet extra a little bit at the end week. But when things were planned like they were more so first semester, when we were doing all of our research, we were getting every task done like way before it was due. So instead of right at the deadline, and then Alex has the next key takeaway.
For our second takeaway is proper communication is needed. And so without sufficient communication, we were kind of stalled a little bit, slowed down. And so what we did was we made a group chat with us, and we started communicating more about what we needed to do, what we needed to get done, and we started finishing on time.
So from a technical point of view, something that we also noticed was that iterations are key. So in addition to just modeling something out, seeing how it looked, actually being able to see it in person, especially with the use of 3D printing that we have here at Oswego East, we were able to better engage with the material. So something like, for example, for the outside of the handle, we modified that about 4 to 5 times in order to get a geometry that we liked and were able to use. And applying this further to the rest of the project would allow for it to better represent and have a better tolerancing and idea of what we want within the project as a whole. Outside of this, we are all really glad, like I was saying, that our project was able to prove what we wanted to prove. And we all each gained major skills, both technically like with the iterations within CAD, but also on a soft skills type basis with communication and presenting and all of that stuff, especially with all that we did with the PLTW program. So again, we wanted to thank you all for coming out tonight, and we just wanted to open it up to any questions that you all might have about our project.
So what was the most challenging aspect of this entire project from beginning to end?
Probably the most challenging aspect was just getting everything in our final design to fit together, because we made individual components first and we tested each component individually, but then after that, packaging everything together, making sure we could spool enough string around the winch on the inside without it jamming, and trying to get the spring not to jam the string too. That was kind of a challenge, and we need a couple more iterations, just redesigning sizes of things just to get it all packaged together.
What portion of the project would you have wanted more time to complete?
So like he was saying, definitely the design work. We were able to work on it for an extended period of time, but as he was saying, it was more of one step at a time. Being able to, if we were to go back, I think we would overlay that and essentially we would be able to use that same time more effectively by having multiple things going on at once instead of incrementally working part by part.
You think having more partners in your team would have helped, or?
I believe that with what we had, we were able to do really well. Of course, having more expertise would be able to help with that, be able to contribute and find problems that we can troubleshoot. However, it all depends on the exact way that would be executed.
That's disagreements between the three.
Whenever the three of us had a disagreement, it's usually on something like the design, like what we think we should use, or what the size something should be, or kind of like the order we should assemble things in. We would kind of just weigh out pros and cons, and then there would usually be a clear one to go with from here.
Kind of similarly, how we had like that, essentially the chart to show the best parts of each thing, of each design, that was able to like show us with numbers like, hey, what works, what doesn't. Of course, it's not something to die by, but it's something to give like a more objective perspective on the project as a whole.
When you were doing your research, did you talk to any of the pole manufacturers or anybody under ergonomics to handle that?
So we did reach out to a couple different ski resort companies who have dealt with skiers' thumb injuries before, and we were mainly asking about if they see, like on the actual slopes, if they see systems to prevent skiers' thumb, like if people actually use something like this and if it actually works. And then we asked, like how comfortable do you think people think it is? And we got a couple of good results from experts. We also went around just on like ski forums on the internet asking what people thought about this design versus something else, and we got good feedback from there.
So what, if you were to go, have you tried it?
So due to like the weather limitations and like the general timeline of this project, we knew from the beginning that we wouldn't be able to finish up our project by the time ski season ends here in Illinois. So unfortunately, we weren't able to do that. However, but it would be a possibility to try if this product were to be continued further.
We did kind of run a test where we had like a mat and pushed each other over.
What about water or snow or ice getting in wreckings? Did you give any thought to preventing that condition?
That was actually one of the issues with the system right here that we saw people complaining with on the internet. And we did take it into consideration, which is we made just our tolerances very, very tight. Like you can't really get ice into the winch mechanism, which is the main part of this that can jam. So because the hole for the string is so tight. So
of course, that is a concern, especially with so many exposed parts. And that is something that we discussed a lot of times. But in terms of a prototype, we weren't as much concerned with that. Of course, with parts like the exposed magnet, that is a concern. However, for the purposes of this project, we were able to find that for prototyping, it would be sufficient.
And is your project, is it a one-size-fits-all?
So essentially how the way that ski pole handles work, and ski poles as a whole, generally you purchase it through the height of the pole, and that is dependent on the person. So the main thing that would be needing to change is the height of the pole. Other than that, the handle, so the part that we were working to design, stays the same.
Skiing was the only use case. I'm envisioning, the off-road running, when folks running up hills and to the poles that they use.
yeah, we actually, in some of our research, we saw like the same company that makes this pole with this release mechanism makes the same exact thing for
And additionally, we found similar patents for biathlons. So not exactly the same thing. However, like they went kind of more about the route of fully disconnecting it. So again, something similar to that. So this general premise can be partially adapted to that kind of field.
And for each, if you could answer individually, what was your favorite part of this project?
I personally liked the CAD modeling process, right? That's just kind of like what I've always liked to do in the PLCW engineering classes, just getting all the tolerances right and then 3D printing it and seeing it all fit together. Like seeing what you make on the computer come to life is always a lot of fun to me.
For me, it was the brainstorming process. What that essentially allowed for was to be able to see all of the different aspects, trying to apply a bunch of different ideas together, and also their execution. And so that then led into the CAD process, which I also massively enjoyed. But that prototyping was essentially like the base, brainstorming was essentially the basis for all of that.
And for me, I liked the building of the product, and there was, when we bought the ski poles, there was handles that came out of it, and we cut the handles open to take them off so we could put our 3D printed our handle on. And I personally just like that part of the project.
I don't know, are we accepting questions also for parents, I believe?
Yes.
Any parents that also have some questions, students back there?
So with your handle, when it disconnects, have you guys considered that as like, I'm assuming like as it drops off the pole, just like drag it behind you?
Yes.
Like, could that damage like other parts of your body, like your arm like getting pulled back?
Yes, so that was a major discussion that we had, especially earlier this semester. Main consensus that we found about that was that it was highly dependent on the length of the string. So looking at already existing solutions and also seeing with our own experiences in skiing, what happens with that, we were able to essentially find that that is a concern, but it is highly dependent on that length. So, and with that is kind of how we found like the 36, 48 inches sweet spot.
We did a lot of playing around with different lengths of strings and ski poles and seeing where they would go, depending on where your arms and stuff were. And we found it didn't really go anywhere where it could hurt you with 36 to 40 inches.
I'm assuming this means that we're